Okay, grade 11 pre-cal, lesson 51, systems of nonlinear equations 2. The second part of this is just some more examples. That's all it is. So let's look at the first one here. So solve the following systems of equations, then verify your solution. So look at the first one. First one's linear. Second one's quadratic. So there's multiple ways to do it. You could either do by elimination or substitution. This one I did substitution, just to show something different. So the first one, what we need to do is rearrange it so it's y equals. So you move the 5x over to the other side. Hey, you got to get rid of the negative, so we end up with y equals 5x minus 10. That's just rearrangement of equations. Now, what we can do is, since it's y equals, wherever we see a y in the second equation, right after the 2, we can plug in that 5x minus 10. So that's all we do. Take the second equation, replace the y with 5x minus 10. Now, be careful, put it in brackets because we're going to have to do distributive property. So we end up with x squared plus x minus 2, right? And that's going to be times the 5x, and then that minus 2 times the negative 10. So we do that. We do distributive property. We end up with the next line here. Collect like terms. We end up with x squared minus 9x plus 20 equals 0. Hey, factor. And always try to factor it first before you automatically go to the quadratic equation. This one factors quite lovely. So we end up with x equals 5 and x equals 4. But you're not done, right? You have to be able to solve for the y values. So what you do is you take x equals 5 and you plug it back into either one of these top equations and get your y value. The same with x equals 4. Plug it into either one of these equations. It doesn't matter which one you plug it into, because again, you're looking for the points of intersection. So it's going to be the same on both graphs. And then you can verify the solution by substituting back in. Basically, that's how you get your answer. So I didn't do the work here, but you can figure that one out. That's pretty easy. Okay, go to the second page. This one here, we're going to do it. This one says solve the following systems of equations graphically, and I'm going to give you a little hint. Always do it algebraically first, and then you can work backwards and solve it graphically just to double check your answer. This one is through technology, so if you want, you can use Desmos or the TI-83. We have two quadratics up here. Again, to be able to solve for these, you can either use elimination, or if you want to plug in the calculator, rearrange them so they equal y. It's actually a good way to do this. Change it. It's good practice rearranging it into y. Get y by itself. Y is positive. Then you can plug the equation into the TI-83. Same with the second one. Take it and rearrange it so it's y equals, right? And then plug that into the TI-83. Graph it, and you can see now this is two quadratics. So in this case, there's actually only one intersection point. How do we find it? We use the intersection function, so you can just do that on your calculator. Desmos, you actually just hover over the intersection point, and it'll actually tell you the point. It's super easy to use. So again, if you haven't used it before, Desmos, D-E-S-M-O-S, Desmos.com. It's a free program, and it's really, really useful to check your answers. So then you plug it back in. You can verify that by plugging it back into the solution. There we go. So that's just more examples of solving systems of non-linear equations.